Hello, welcome. Good afternoon. Welcome at the final exam review session. Let's finalize our Calculus 2 adventure. I hope you're gonna take maybe Calculus 3, maybe differential equations, maybe Math 220 matrices. Depends on your schedule, depends on your path. Are you going to take another math class? Yes, of course. We always have to learn math every day. Okay, just one student? Aravinda, just you? Probably more students. I know that more students will take, especially the software engineering path. I think you have to take, yes, differential equations, right, yes, yeah, okay, but let's finalize, because we have to be confident with, in order to take differential equations, we know how important are integration, differentiation, integration, and even the power series, because we may ironically simplify our work, rewriting a function as a power series, and then power function, so easy to differentiate, integrate, we can do everything. That means that will be a good tool. Okay, but for now, we still have to, finalize Calc 2. The test will be open this Friday, and I think it's August 4th, and will be logged next Thursday. Okay, that's, we have plenty of time. You may pick your time, your day, the most convenient for you to take the test. That's mean, please do not wait until the last minute, because we never know, always things can happen, and then we will have not enough time. Yes, and it's after Thursday, we cannot do anything. The test will be logged. I know that you are planning. The way to take the test is exactly the same like exam 1 and 2, through Canvas. However, the honor log is involved. And then this is just like the approximate distribution of the question. Half of the test will be from the old material, exam 1 and exam 2, which you may definitely look at the sample problems, okay, that we provide for you, and practice, review this again. And then another half of the test will be the new stuff, meaning I think was chapter 10, section 10.6, 7 and 8, and then chapter 11, and that's it. That means it looks like, but this is like the approximate breakdown. And the total points 200, we know the rules, and time will be a little bit longer, 140 minutes. Because number of questions will be just a little bit, a little bit. I know that the number of points is more, but number of questions will not double. Oh, no, you will not have. It will be still around 20, 25, depends. Multiple choice or the drop down menu, depends. Depends on the question. Okay, and then that's the material. I think we did a little bit of the review of this integration, and then chapter 7, and then the L'Hopital rule, which also was the review, just separable differential equations, and then chapter 10, and that was the material after exam 2. That's mean what we will do, we will try to review chapter 10 today, okay, only chapter 10, starting from section 10.6 and then 7 and 8. And tomorrow or Thursday, you have to check the calendar, the review session with Caroline. She will cover chapter 11 and also the differential equations with power series. Okay, and we remember we just touched the topic, was just one type of question. That's mean you will have this tomorrow, but today let's focus on chapter 10, what kind of questions we can have. That we will not review, but I will really recommend reviewing exam 1 and 2, even rewatching the review session. and definitely working on the sample problems. Oh, for the final test, actually, I did release like sample tests. Yeah, I hope you will like it. I don't know, sometimes it's nice to have a list of problems rather than the set of problems as a one test, but I think will be helpful too. That's been definitely solving 4 of them. Yes, A, B, C, and D. 4 of the sample tests will be like excellent practice. And then practice test for the extra credit, and yeah, and then the final test. But please take everything seriously. We know that. Okay, that means I will skip. I have a couple of questions, but I will skip them. Actually, yes, let's, because then we will focus on them. If we will have time, we can come back. But this is the list of the sequences. I thought that I have my solutions. I have to add them. I have for some of them. Yeah, that means make sure that just basically by looking, yeah, don't spend lots of time, because at this point we really have to be like, yeah, confident. Just by looking, you will know the answer. Yeah, like for instance, maybe number 2. Do you know number 2? This is sequence. 3, 4. I was planning to skip that page, but what about number 2? Is this sequence convergent or divergent? I'm just testing if my students are ready to take the test. Yeah? The sequence, that we remember when it's sequence, we do not apply any tests. We're basically looking at the limit at infinity. That's it. And we know that this one is convergent to e to the power of 6, right? This one is convergent to E. We know that. This one is, oh, wait a minute, divergent, okay. This one is actually convergent to 0. And this one is divergent. Okay, I think you can see, you can think, yeah. I will put a little bit more details, but that's how I would like you to, yeah, but that's the old stuff to solve the problems. Yeah, no, like it's no time for, yes, for deeper, like, yes, investigation. Okay, and then I have another list, beautiful, and another one. And okay, and that's it. That's for the sequences. But okay, let's jump. This is one question. I did solve it, but you may definitely cover the solution and try to solve it on your own. Another one. We did this. Some of them are from exam 2, yeah, because that was chapter 10. Okay, but I would like to focus on the new material. Okay, that's in power series, and then Taylor and Maclaren. From the power series, you will have just standard question. Find the radius of convergence, find the interval of convergence, and find the power series representation for a certain function. Okay, that's basically it. 3 questions, 3, maybe 4 from 10.6. Let's look at this. Find the radius of convergence. Yeah, and then I just pick an example. If you need more examples, you can definitely open a textbook with section 10.6 and find the question and just practice and practice. The full solution is posted on Canvas. Yeah, we know that for every single question from the textbook. Okay, what you will do to find the radius? Who can tell me what test we will use? Ratio test. Thank you. Let's do it. Let's see how many questions we can solve during 1 hour. Okay, limit as n goes to the infinity, and we just need that ratio. Absolute value, limit as n goes to the infinity. And then, okay, I will add 1 to n plus 1 factorial. 4 to the power of n plus 1, which is this. And then when we adding n plus 1, I mean adding 1 to the n, and I will distribute that too, then we will have 2n plus 3. Okay, I would like just to, because will be 2n plus 2 plus 1, okay? And then x minus 2 to the power of n plus 1 looks like this, because this is 1. Okay. Now dividing by fraction means multiplying by reciprocal. That means I will put this 2n plus 1 on the top, and then n factorial, 4 to the n, and x minus 2 to the n. Yeah, nice, because we know that this will be simplified a lot. Let's see. This is gone. Oh, wait, this is gone. Maybe n plus 1 factorial. Yeah, I know that you so good. That means I can do a little bit faster. N plus 1 factorial is n factorial times n plus 1. And I can cancel n plus 1. Also, 2n plus 3. Yeah, 2n plus 3, I can rewrite as a 2n plus 1 factorial, like 2 number less, and then 2n plus 2, 2n plus 3. Yeah, that means this is this. I know I'm just, and we may simplify. Let's see what's left. Maybe I can write a little bit lower. Do we know the limit? Who is faster than me? I think everybody's faster. Okay, 4. And then, oh, everything is gone. 2n plus 2, 2n plus 3. And then we have x minus 2. And I will keep absolute value because we do have absolute value. We don't have to keep on n because n's are the natural numbers, positive. Then we don't have to have absolute value, but x could be any number. We have to keep absolute value. Yes, thank you. N plus 1. Yes, thank you, Deepan. I was looking, yeah. And you remember, I'm kind of like separating the n's and the x because the limit has to be calculated, like we have to look at the n's. X minus 2 is constant with respect to that limit. Okay, that means what is that limit? 4n versus 4n squared. And this limit is 0. Then 0 times anything, any number, it will be 0. So now what are the conclusions? 0 is always less than 1. That means this power series is convergent for all of the numbers. Convergent like always, because by the ratio test, convergent for all x's. Yeah, from the real numbers. Then what is the radius? Of course, I see the answer on the chat box. It's infinity. Yeah, that's when you can see when you will get 0 by the ratio test, radius is infinity. If you will get infinity, radius is 0. Yeah, just a little bit of technical suggestion. Hint. Okay, we know the radius. Now, oh, and if this question will ask for an interval, what's the interval? Of course, nothing mysterious. Yeah, all of the numbers. Okay, great. One question done, 8 points. Okay, interval of convergence. Power series -1 to the n plus 1, 1 over n2 to the n, x plus 2 to the n. Yeah? First of all, because we're looking for the interval, what is the center of this interval? Do we see from it's -2? -2, yes, because it's x plus 2. It's always x minus a quantity, and that quantity, subtracting negative, it's positive. That means -2 is a center. I'm just asking because, yeah, 2 reasons, like just to check if you can, because it's helpful sometimes. And then we may sometimes eliminate some of the options right away. But I think all of the provided intervals, they have center -2. Definitely this one, all of them, yes, -2. We're just going away half of the unit, yeah, the radius is different, but center is -2, okay? Then the same thing. Let's start with the ratio test. Okay, limit as n goes to the infinity, a sub n plus 1. Oh, my writing is over a sub n. Okay, so we will have x plus 2 to the power of n plus 1. That's this. and then n plus 1, and 2 to the n times 2 to the 1, which is the same. And multiplying by the reciprocal will be n, 2 to the n, x plus 2 to the n. Absolute value. Negative 1 is gone because absolute value is taking care of this. Okay, we can definitely simplify this and this and this. Then what we have? We have just n, and we have 2n plus 1. And this, am I right? I'm separating. This is times. Only n, it's important, every single coefficient, because it has to be symmetrical about, yes, Scott, yes. Like negative 2 is a center. That's mean we will just go, I'm just looking at the chat box now, yes. Okay, that's mean now, what is this limit? This limit is at infinity, as n goes to infinity, n over 2n. This limit is 1/2. It means the final answer for this limit will be 1/2 times x plus 2. Okay, and the answer depends on x. We know the condition. We remember the ratio test. For the ratio test, the limit, that ratio, of that ratio must be less than 1 for convergence. That we have to solve inequality. We may get rid of that 1/2. I will multiply by 2, and we can see, yes, we can see because I hope we can read absolute value inequalities. Going away from -2, we're going just 2 units, yes, 2 units away, because this quantity must be less than 2 and greater than -2. That means the radius is 2, which this and this option will be wrong, because that radius is 1/2. Okay, but now let's see, we have to solve it. That means that's actually, this step is important. We subtracting 2, this will be -4, this will be 0. It means the potential interval is between -4 and 0, but we still have to test the endpoints. It's just 2 points. Then we simply substitute it. Okay? Because we don't know from -4 to 0, but I don't know if it's open. Yeah, that's please do not select this right away. I'm meaning option C. Okay, what is happening at -4? I will copy everything. Now we have to copy the entire formula. 1 over n to the n, and instead of x, we will put -4. -4 plus 2 to the power of n. Okay, what's going on? -1 to the n plus 1. This -4 plus 2 is -2. -2 to the power of n is -1 to the power of n and 2 to the power of n. I hope this makes sense. Okay, because this is -2. That means we have -1 and 2. I can cancel this. And now let's check if we have only n. Let me write here. That's we have 1 over n harmonic, but if it's alternating harmonic, it is convergent by AST, right? But if it's just harmonic, it's divergent, of course. Or if it's negative harmonic, also divergent. So we will have -1, n plus 1 plus n will be 2n plus 1. And now let's think, 2n plus 1, the exponent. What is the number 2n plus 1? 2n plus 1, 2n plus 1 is always the odd number. 2n plus 1. Whatever we will substitute instead of n, we will have an odd number. -1 to the odd number is just negative. That means this expression will be simply negative. It's not alternating. That we do have, actually not 0, because we have n in the denominator. 1, 1, 1, 1. Okay, that means this one is actually divergent. It's harmonic, all of the terms negative, but still huge. That means this one is divergent. We will not include -4. Okay, that means we will not include -4. Let's check 0. We will get probably alternating because this is alternating part, n 2 to the n. When we substitute 0 instead of x, we will have 2 to the n, 2 to the n, 2 to the n. This means the final formula is -1 n plus 1. This means this one is alternating harmonic. Yeah, this one is alternating harmonic convergent. We will include 0. This is the final answer. Not this one. We will include 0. Okay, that means, yeah, interval maybe is a little bit more time consuming, but yeah, quick. You will not really talk loud, then you will solve it quickly. Okay. And for instance, find the power series representation. Express a function x over x plus 3 as a power series. And we like the shape because we know that when we have quantity 1, I mean 1 over quantity 1 minus x, this is simply the geometric one, is just x to the power of n. All right, that means this is important. This formula only works when x is between -1 and 1. Yeah, radius, center 0, radius 1. Only -1, like the geometric series. Yeah, we remember common ratio must be between -1 for convergence. Okay, that means now we have our function looks similar. The bottom formula is the tool. That means we do have x and x plus 3. Luckily, we don't have to use the integration, differentiation. No. I will put x in front. Let me change the direction, order. Okay, that's mean we do have 1. I'm trying to get that form 1 over 1 minus a quantity x, quantity. That will be and that quantity, actually, this one goes there. But let's get that form. Okay, that's mean what we have. Also, we don't like that 3. That's mean I will factor out 3. It will be 1 plus x over 3. And one more step. Correct, 1. We don't like addition. We would like to see subtraction. That's mean, yes, we have 1 minus, and this is the common ratio. That's mean I can basically copy this to the power of n, and that's the formula. But I still have to keep this because this was part of the function. But we can see that's what we will do. It's just this. But now let's combine everything nicely. We have negative x over 3 to the power of n, -1 to the n, x to the n, 3 to the n. And now in front, we have x to the power of 1 and 3 to the power of 1. Do we know what we can do? We can, because we have to put behind sigma, +1, +1, because that's the powers. And this is the final answer. That's the power series representation. And just in case, if we will ask for the radius, that moment, yes, this is that common ratio. That means this quantity, -x over 3, absolute value of it must be less than 1. That's how you can get a radius or even interval. Okay, that means this is this, and let me just do this way. Okay. And let's solve it. We may skip the negative because absolute value of negative is positive, multiplying by 3. Okay, that we can see the radius is 3 and interval is between -3 and +3 because absolute value of x will be between -3 and 3. Okay, just in case if we have to do it. But this is that moment, that formula that we may put to the condition. Okay, and I hope we see the correct answer somewhere is this one. Plus one. Also be really careful. Yes, really careful because all of the options are so similar. Okay, we good with 10.6. Perfect. Most likely, in like this long questions are worth 8 points on the final test. 8, 8, and 8. 3 times 8, 24. You earn 24 points. Okay. Half of the quarter because it's 200 points. Okay, I have another one, but you can try. It's the same way. Yeah, find the power series representation for the function x over 1 plus x squared. So similar. You can copy the process that I just did. Okay. And then 10.7, 10.8. We do have this Taylor, actually Maclaurin, because all of them are centered at 0. Normally, we will ask you to memorize this, but we will provide these formulas. Okay, that means you will probably see them somewhere typed on the final test. Okay, yeah, that's we have to know them. We know how we like discover them, how we like derive them. Some of them just came from this basic geometric one. Some of them we use the Taylor formula, we remember. Okay, I mean, they are nice, and let's see how we can test them, but they will be provided. But we have to know them, not just thinking, okay, they will be provided, I don't have to really think. Yeah, we have to still be aware what is here. Okay, let's just, okay, I copy this. Okay, that's mean for yeah, let's actually, okay, let's leave it. Let's leave it. For instance, this one, right? For each of the following series, find the sum or determine that it diverges. 1, 2, 3, 4. That means they are not power series, yeah, but they have, yeah, they have formulas that we can recognize. Okay, that's which one you recognize. We can see they are all alternating. Let's look at them again. Alternating. This one is not alternating, but yeah, and it's maybe worth to look at the denominators. N factorial is for e to the x. 2n plus 1 factorial, sine of x. 2n factorial cosine. 2n plus 1 without the factorial, it's arctangent, inverse tangent, and just n is for natural log of 1 plus x. But that x also must be between -1 and 1 only. That means maybe we can do this way. That means, for instance, what we see. Oh, actually, the first one, first one is just quantity to the power of x. Just this. That means where am I? Look at the first one. We have -1 to the n, we have 6 to the n, and we have 5 to the n. If I combine everything, -6 over 5 to the power of n. Okay, that means looks like x to the power of n. However, that x, yeah, that means it looks like x to the power of n. And we know that this is the geometric one, and we may use, let me just do this. This is equivalent to that function, but the condition is x must be between -1 and 1. That's what's happened in our situation. Yes, Deepen, you're right. It is divergent. I will not even make the connection. That means actually we're not allowed to use this formula. Right? It is divergent because -6 over 5 is outside that interval. I mean, this one is actually divergent. Okay, divergent because of that x being outside the interval. Okay, number 2. What we see. Yes, really good, really good. We have the alternation. We have 2n plus 1. And the quantity to the power of 2n plus 1 is 3 over 5. 2n plus 1 without the factorial. That means you can check the formulas, will be arc tangent of that number, yes, x, but x is 2/5. And this is fine because this is number between -1 and 1. Because for the arctangent, let's look at this. For the arctangent, we also have radius is 1. As we can only go 1 unit away from the center. Center is 0. Okay. What about number 3? Almost the same thing, but -1 to the n, 2n plus 1 factorial, and quantity to the 2n plus 1. Yeah? This one is sine of 3/5. Actually, sine could be any number, because sine and cosine and e to the x, any number. And we don't know these values, we can just leave it like this. And the last one, can I say right away, cosine of 3/5? Because it's 2n factorial, even numbers, everything match. Okay, that's how we can recognize them. Okay. Oh, this one is interesting. The same idea, the same question, a little bit of the trick. Find the sum of the series x to the power of 4n over n factorial. That means just n factorial. What formula will be this one? If we have just quantity x to the power of n over n factorial. And this one is e to the x, right? Yes, e to the x. Thank you, Joseph. Thank you, Joseph. And then when we expand this, it will be 0 will give us 1, and then 1 factorial x to the power of 1, 2 factorial x squared, 3 factorial x cubed, and so on. That means this is e to the x. Now, what we have? You may notice one thing, yes, we're not starting from 0, we're starting from 2. But let's actually see, we have quantity to the power of n factorial, and the quantity is x to the power of 4, right? And what we can do, how we can, yeah, we just, what is important, we just missing, oh, let's actually, okay, let's say this is from 0. Okay, let's say this is from 0 for now, it will be easier. Then when I make the expanded form, okay, 0, if it's 0 factorial, it is 1. Then if it's 1, is x to the power of 4 over 1 factorial. And then x to the power of 0, 1, 2, 8 over 2 factorial. And then 4 times 3, 12 over 3 factorial, and so on. And this, everything, actually this formula, I can just say is e to the power of x to the power of 4, because it's just that quantity. Yeah? It's just this one, x to the power of 4. We can say it's just e to the x, e to the x. But what we missing, yes, in our, like, I mean, what is the difference? I cannot just say this, right? If this will be from 0, yes, we do not include n0, the term defined for n0 and for n1, because we just starting from n2. That means everything it's named e to the power of x to the 4. But if I would like to start from n2, not including this, I will have to, from everything, we can see this is everything. I'm subtracting the first, actually, 2 terms. Make sense? And then this will be that formula, but starting at 2. N factorial quantity x to the power of n. That means this is everything, but not including the first 2 terms. We have to subtract them. So please be really careful. Yeah? It's also testing the formula that is provided, but a little bit, yeah. Okay. Hope we're good with this one. Oh, and another one. Similar. Yeah, similar idea. we see the formula, we know the formula starts with 1, okay? And it's -1 to the n minus 1, x to the power of n over n. Yeah. And actually, I supposed to start, it's okay, I can do, it's natural log of 1 plus x. 1 plus x, okay? 1 plus x. And also, it's really important that x, it's only between -1 and 1. That's what we actually see. Let me rewrite this. We have to pay attention to the index -1 to the n minus 1, correct? And then 1 plus what quantity I have to put to get 0.2? Actually, am I... oh, I'm just thinking my answers are not matching, or maybe I missed. Oh, no. Oh, wait a minute, because I did create this. I have to look at the test. No. Let me think. I mean, we can. Did I make the mistake? I'm just thinking, that wasn't my intention. Okay, let's say 1. Okay. But yeah, okay, no, I think I wanted 1, but just in case, 1 plus what number to get 0.2? That was my original question, just in case, because it will be still okay. But I think that wasn't, yes, that's what I was thinking, -0.8, and it's still fine. It's still in that range, it's still fine, -0.8. Okay, that means this will be the x. Let's just, how can I do this? -0.8. Yeah, that means this will be that x quantity. And then I can just say it's natural log of 1 plus x. And the x is -0.8. We can still, and this will be just natural log of 0.2. Yeah? If we will start from 1. Yeah, that means that if we're not starting, we have to like subtract these terms, whatever is the number that we're missing. Okay, that we can see this. But no, but yes, -0.8. That was my point. Now let's actually do whatever I was thinking to do. Let's put 1. Okay, let's put 1. Then this is this. Okay. That's what 0.2. Then it's not a problem. You even answer this question. Okay, and we're starting from 3. I hope one of the answer match. Okay. No. No. Something is wrong. Am I? No. I think I'm getting. No. We don't. Oh, no. Everything is correct. Everything is correct. Oh, well, because that's not a formula. This is still this. I mean, this is the formula. Oh, no. Let's come back. I think we have everything set. Because this is just x, right? This is just x. I think I mixed both of the, oh, well. Okay, that means normally we will say that it's natural log and 0.2 is that x quantity. Yes, and then we will say it's 1 plus 0.2. Please ignore my arithmetic that I was trying to put. Do you think that's correct? No? I mean, some small mistakes because we still have to subtract. Yes, that means this is, No, because we look at this. Yes, look at this one. I can even, let me just put 1, because this will be the direct formula, because I'm trying to, okay, that's me. No, this is correct. Okay, if this will be the question, it will be just natural log of 1.2. Yeah, that's me. No, we're not subtracting. I think I mix the left and the right hand side of this. I don't know why. I was trying to keep this one as a 1 plus x. Yeah, no. Now, okay, let's make sure that we understand this. We still didn't answer we still don't have the right answer. Because we know why, because I'm still trying to challenge you with that 3. And at the moment we have 1. Okay, that's me. Let's do this, because this is the formula. You can even check. Shall I come back for a second? You will check. Okay, is this formula is starting from 1? You will check. You will have everything. And we know what is x. In that formula provided, quantity x is 0.2. Okay, that's me. No, yes, no. But now, when we expand this, let's expand this. Looking at this is just looking at the power function. If n is 1, then the term is actually positive. N is 1, it's just 0.2 to the power of 1, right? Now, then if n is 2, the second term, this will be negative, and then this will be 0.2 to the power of 2 over 2. Then if n is 1, 2, 3, 3 minus 1 is even number, this will become positive, 0.2, that's the x, to the power of 3 over 3, and so on. Now we can see the pattern, 4 and 4, and so on. That means this is, one more time, this was defined for n1, this is for n2, this is for n3, and everything together, everything together is this natural log of 1 plus 0.2, which is ln of 1.2. Yes, 1.2. But what we have to subtract, because we do start from this, that means from everything, from the natural log of 1.2, we have to subtract the first 2 terms. That means, let's see, we have to subtract. This one will be gone, and this one. We have to subtract this. I mean, this will be actually the answer. How can I do? This is the answer. Then we will have everything, right? Everything is named natural log of 1.2. We know where this comes from, and minus the first term and the second term. Oh, it is tricky. Oh, well, because it's negative. Oh, I think I did a lot. These 2 terms I'm trying to subtract. Okay. I hope one of my options match. Okay, that means this is the final answer, because we did start from 3. That means everything starts from 1, and we don't have these 2 terms. We have to subtract. Okay, that's we okay with this, I hope. Minus 0.2, negative, and subtracting negative will be positive. Oh, what is 0.2 squared? It is 0.04 over 2. Am I right? And then we have 0.2 plus 0.02, because we have to divide. And then this is 20. Then this will be 18. Please check. Of course, no calculators. Natural log of 1.2 minus 0.18. Please confirm that I'm right. Okay, that means option A is a mean option. Okay, thank you. Because what we're doing, we have to subtract the first 2 terms, but one of them is negative. Subtracting negative, as we can see, I did subtract. Okay, it's a nice question. Nice question. Okay, nice question. Probably the easiest version of this question is just starting from 1, n equals to 1, and option C will be the answer. Okay, that means please forget about this negative 0.8. That was, I totally mixed this and this. Okay, now with the sigma, with the power series, we have just x, and that x will go to this 1 plus x expression. Okay. That means I will check. I promise I will give you the easiest version of this question. Okay. It's still a nice question. I think it's because the formula is provided. That means it's almost just here, just thinking, yeah. Okay, we did correctly. Let's keep moving. Oh, something like this. Okay, we have to be able to integrate or differentiate some, again, the formulas that are provided. Almost no, yes, no, new thing. That means what we see. We have to evaluate this indefinite integral as a power series, Maclaurin series. Yeah, it's of course power series. And we can see sine. We know the formula for sine of x, the power series representation, the Maclaurin one, because it's centered at 0, is -1 to the n, x to the power of 2n plus 1 over 2n plus 1 factorial. You have this formula provided. Okay, so now let's see. We do have x cubed, and we have sine of a different quantity. Let's see. Again, let's don't mix this. X and x. That means our x, our quantity is x over 2. Okay. X cubed. That means this can be rewrite as a power series, Maclaurin, -1 to the n, 2n plus 1 factorial in the denominator, and then quantity to the power of 2n plus 1. And what is the quantity? Who can help me? Because I need help. It's that x over 2. X over 2. Okay, let's rewrite a little bit because we know that in order to integrate or differentiate, we just taking that x, everything like n, all of the constant are constant. We just copy them. Okay, that's mean what we will have. Let's rewrite, because at the moment x over 2, we can't integrate right away. This will stay. This will stay. X over 2 to the power of 2n. This means that we have x to the power of 2n plus 1, and 2 in the denominator to the 2n plus 1. Okay, makes sense? X to the 2n plus 1 and 2 to the 2n plus 1. And we also have x cubed. How we can move that behind the sigma? That means I would like to remove this and add 3. Yeah, that's mean now I have just one like a variable. It's mean integrating, let's see, -1 to the n, and we have x, this is constant, 2n plus 1, 2 to the 2n plus 1, and 2n plus 4. Okay? And I can rewrite one time, but you may probably integrate from this because you just have to integrate this. Oh, dx. That means I will copy everything, constant, of course, of integration. I will copy, let's actually wait a second, because we still didn't integrate. One more line. I could, but I would like to write for you that we just integrating that part. Do you know the answer? You probably know the answer. Okay, that means everything else we will copy. This doesn't have x. 2n plus 1 factorial doesn't have x, is a constant coefficient. 2 to the 2n plus 1. And the only thing that we have to integrate is this one. 2n plus 4. This is n. Okay, That's what is the integral of x to the power of 2n plus 4? Constant. Now I can put the constant. Please just tell me the integral. You can type. Oh, what I did? Oh, no. Where am I? Here. Okay. 2n plus 1 factorial 2 to the factorial 2 to the 2n plus 1. And what's the integral? Yes, Thomas and somebody else, I don't know the name. We will just add 1. 2n plus 5 all over 2n plus 5. And nothing, yeah, we don't have to simplify. Okay, that's the final answer. But we can see how you can skip some of the steps. Oh, I know that the blue coefficient you can add right away, and yeah, you can integrate. Yeah, you don't have to. I just wanted to put all of the steps. Yeah. Okay, that means the final answer. The final answer, I think, is again E, or maybe I'm wrong. 2n plus 5, 2n plus 1 factorial. No, correct. Okay, that's the way. And I have, oh yeah, you can check this one. I was just taking something from Achieve. This one will be the same idea. X times cosine, okay, of x to the power of 4. Find the formula, the Maclaurin series for cosine, which is the power series. Substitute instead of x to the power of 4. Adjust with that extra x to the power of 1, and then integrate. You can do it. That's the same thing, but inverse tangent of x over x. You may cover this and then look, okay, what is done. And okay, what we also have to know, I know that we Taylor polynomials and the error, okay, in the approximation. That means let's maybe do one. Shall we do this one? Okay, this one has the option. Let's do the option. We can see this one. This question is asking for the Taylor polynomial, degree 4, okay, but cosine function, but centered at pi over 2. That means it's different center. I will try to do it from the scratch. I will not use the given formula. If the center will be 0, yes, then we can rewrite, we can have expanded form, and we can get just the 4th degree. Okay, that's what we need, 4th degree. We remember, we will need the value of the function at pi over 2. We will need the value of the derivative at pi over 2 over 1 factorial, x minus, to the power of 1 actually. And then second derivative, 2 factorial, x minus the center to the power of 2. Third derivative at the center, 3 factorial, x minus to the power of 3, and 4th derivative at pi over 2, 4 factorial, x minus. And I will really suggest to write this down. It's 10 seconds. Okay, because then you will not make the mistake. Okay, that means let's maybe build that table that I was building. Function is defined as a cosine of 2x. And then we will need value of the derivatives at the center, pi over 2. Okay, 0 means the function. First derivative, second derivative, and the 4th derivative. Okay, function is just, my pen is not writing. Function is just cosine of 2x. Okay, first derivative, because this means derivatives. The option C is the correct answer. Let's check. Derivative will be negative sine of 2x times 2. And then derivative of sine of 2x is cosine of 2x times another 2. Derivative of cosine is negative sine of 2x times 2. And derivative of sine of 2x is cosine of 2x times 2. That's the answer. When we substitute pi over 2, pi over 2 times 2 actually becomes pi. Okay, that means what is cosine of pi? Cosine of pi is negative 1. then what is negative sine? Actually, sine at pi, 0, sine at pi, 0. Cosine is -1, then this will be +4, and this will be -16. Okay. That's what is the correct answer? Which option you will not choose? Okay. That's actually, yeah, that perfect, because and actually this one, because we have to subtract the center, and x, we can see nothing is subtracted, but also not the option E, because they have just the values of the derivatives. We still have to remember about these factorials. Okay, that means the first derivative is gone because it's 0, and the third derivative is gone. Perfect. Then this value is -1. Second derivative is 4. Then 4 over 2 factorials. That's what is missing sometimes. And then the fourth derivative is -16 over 4 factorial. Okay. And when we do the arithmetic for the factorials, 4 over 2 is 2, and am I right? -16 over 24, 2/3, -2/3. That means this is the correct answer. Okay, yes, option C. Okay, but please, please make sure that you know how to do any Taylor polynomial, because you can just find derivatives, the first, second, third, fourth, and so on. Okay, now that's the same question. Okay, and this is, something is wrong because my typing is probably wrong. I'm supposed to provide you the derivative. Okay, but okay, I think I didn't type. Do you see? I didn't type the derivatives. Because the third derivative, that means this is the third derivative and this is the fourth derivative. Okay, provided. Okay, let's see. We have a function and the third and the fourth derivative. Use error bound to estimate the accuracy of the approximation function by the third degree Taylor polynomial centered at 3 on the interval between 0 and 6. That means 3 is center and we're going 3 units away. For all of these values, we can do the approximation, but how good it is, how small is the error. Error bound. That's what we're doing, taking the entire function and substituting the approximation. And this is error. We will have some error. And we know that this error is less than or equal to then the next term. That means if actually sometimes we can say like reminder error, the same thing. Yes, the same thing. It will be less than the next term. That means this will be n factorial, which will be, it is third degree. That means this will be 4. This will be x minus the center to the power of 4. And this is also the fourth derivative. But we remember we put in kind of like a number k or m, let's say k, because this is the maximum value of the fourth derivative. And we know why is 4, because we're doing the third degree approximation, is the next term. Okay, that means k is maximum value of the fourth derivative on the given interval. Okay, that means what is k? We have the fourth derivative. Fourth derivative is equal to e to the power of x over 3 over 81. 81. That means what value we have to substitute from the interval to maximize that number? Yeah, I will basically put 6. Because this is the maximum. If, yes, thank you. You actually, yes, you're actually helping me. If you have a formula for the derivative and x is in the denominator, then pick the lowest value. Hopefully it's not 0 because we can't put 0. It will be different, but I'm just saying in general, minimizing a denominator, we're maximizing the number. But maximizing numerator, we're maximizing the number. That means it's e to the power of 2, e squared over 81. This is the k number. E squared over 81. 4 factorial is 24. And then x, we also have to substitute something for x, but could be like, yeah, we have to also maximize this distance, x minus 3. We can substitute either way. We can substitute 0 or we can substitute 6. We will get the same value because it's absolute value. Always the endpoints. And the final output of this quantity is the radius. That's when I put 0 minus 3, it's 3. 6 minus 3 is also 3. 3 to the power of 4. Okay. And let's maybe put the final answer here. Is 3 to the power of 4 81? I think so. E squared over 24. E squared over 24. Okay. Am I right? Yeah. Okay. But definitely the error bound. Definitely. Okay. And one more question. One more. You can do this. It's also the error. You can approximate. It's the error. Please solve them. Okay. I will add my writing, but please practice. And this question, you probably saw on the quiz this week, but let's check if you can tell me, am I right? Yes, okay. That's what we have. Suppose that this is the 6th degree Taylor polynomial centered at 2 for the function f of x. Okay? And we don't really see the function, and this is just the polynomial. And now we have to find out what is the value at 2, what is the first derivative at 2, what is the second derivative, third, fourth, and fifth. Okay. That's do we know what we will be doing? When I will write let's say the 6th degree, you remember what I will say? I will say the first value is the value of the function at the center, and then is the first derivative at the center. Actually, I don't like squeezing this. Okay, that means this is just knowing the formula. Function at 2. First derivative at 2, 1 factorial, x minus 2. And then second derivative at 2, 2 factorial, x minus 2 squared. And then third derivative at 2, 3 factorial. And fourth derivative at 2, 4 factorial, x minus 2 to the power of 4. Okay, I don't have enough room. Fifth derivative at 2, 5 factorial, x minus 2 to the power of 5, and one more, 6th derivative at 2, 6 factorial, x minus 2 to the power of 6. Okay, that's mean now we can match. Yeah, oh, you have all of the answers. That we can definitely see this is this. Right? That means f of 2 is just 2. Perfect. Now, first derivative. That means first derivative is sitting here, and that's the coefficient. That means first derivative at 2. Actually, 1 factorial is 6. That means this one is easy. Oh, why I'm writing at 2 is just 6. Okay, because the factorials are important. What color? Blue. Okay, what is the second derivative? I see second derivative will correspond to this one. That's what is the second derivative at 2? It's 7 times 2 factorial. It is 14. Can I write like this? Because I already, okay. What about what color I can pick? Blue, the other blue. Okay, this, the third derivative, yeah, -5. Yeah, this is just, that means please do not just say that this is like -5, because we still have, okay, that means the third derivative at 2 will be -5 times 6, -30. Okay, what about the fourth derivative? Who can tell me the fourth one? Fourth derivative actually is 1. It means the fourth derivative at 2 will be 1 times 4 factorial, 24. Okay, and oh, what about the fifth derivative? Fifth derivative at 2. Do we have a coefficient of 5? No, 0. I don't know how to 0. Okay, no. Then fifth derivative is actually 0. 0. And then what about the sixth derivative? Sixth derivative, I can see some, what color I can use? This is the sixth derivative and -1/3. Let me, okay. Sixth derivative at 2 over, oh, wait, over 6 factorial -1/3. Then sixth derivative at 2 will be, what is 6 factorial? We can actually write 6 factorial over 3. If it's too big number, we will leave it like this. It's 6 factorial because it's 120 times 6, 720. And 720 we can divide by 3. Yeah, that's probably we can do it. What is 720 divided by 3? 240. Yes, I'm just, yeah, -240. Okay, but we can see the point, yeah, just again, knowing the formula of the Taylor polynomials, Taylor series. Okay, that's it, that's everything. And please, yeah, whichever questions I skipped, please try to solve them, and I will definitely add. Yes, I will definitely add the solution. You will see the entire slides. You have the video, and yeah, please, practice. Join the other review session and do the sample test, do the practice test, and I'm sure you will ace it, your final test. Okay. Okay, that means thank you very much for the entire semester. I believe it was a little bit too short. Yeah, summer also, and we were splitting teaching with Caroline, but yeah, I still get to know some of the students, most of the students. Okay, practice and enjoy, yes, the rest of your summer, after finishing strong Calc 2. Okay, and good luck with your next math classes. Thank you so much. Thank you.